Hello students, this is the third video in series of testing the equality of one population parameter. Now we'll talk about part 4, and question number 4 says test the hypothesis at 0.05 significance level that the standard deviation of wage differs significantly from $10. So first of all, we are going to do the write-up for this. Test of sigma or the standard deviation of one population. H0 equals or states that sigma is equal to 10, whereas H1 says sigma or standard deviation differs from 10. Level of significance is given as 0.05 that can be divided again by 2. Test statistic is chi-square because for one population variance testing chi-square is used as it gives a relationship between the population standard deviation and its sample counterpart. So chi-square has this formula: chi-square equals n minus 1 times s squared divided by sigma squared. Critical region, instead of decision rule or criterion we define here in this case, because we are going to do this manually following classical approach of hypothesis testing. And for this we need to draw chi-square curve where we need to introduce two rejection zones, first one on the right tail part under the curve and second one on the left hand tail part under the curve. And there is a norm to indicate two chi-square values in this way. Chi-square 0.025 we can indicate upper bound as, and the borderline that we have indicated on the left hand side under the curve as the left tail critical line or borderline, we stated this as 1 minus 0.025, that's the area below this borderline, and 1 minus 0.025 gives us 0.975. Now I will open the chi-square table. It's over here. The degrees of freedom in this data file are n minus 1, that's 100 minus 1 because there are 100 observations involved in this. So if we go to chi-square table, the very last row indicates 100 degrees of freedom and the previous one is indicating the values for 90 df. So preferably we can go for 100 because that's the closer one, and the middlemost column is indicating the value corresponding to the lower bound of chi-square table, and lower bound under curve as chi-square 0.975. So that's 74.222. And if you go to the next page, again the very last row, we will choose 129.563. So 129.563 and then the lower bound value is, or the left tail critical value is 74.222. With same degrees of freedom as 100 we have considered, and we state our decision criterion. All over here, critical region as H naught would be rejected if chi-square calculated is either less than 74.222 or it is greater than 129.563. Now we go for computation, and nothing to worry about because everything we get in the output table. Now, since we cannot perform chi-square test for one population here in this case, so better to go for descriptive statistics. From there we will determine or get the value of standard deviation. Descriptive statistics for the wages, and it gives the sample standard deviation value of 19.059. So standard deviation of the sample is 19.059. Now we substitute in the formula. N is 100, so 100 take away 1. That's 19.059 squared divided by 10 squared. This is sigma square mentioned, or sigma mentioned in the H naught will be used, and we will raise it to square so that we can compute the value of chi-square statistic. That we got as the answer is 359.61, which is clearly falling in the rejection region. You can see if we compare it with 129.6563. So this is the case of rejection. So over here we write down our decision and conclusion as since chi-square calculated falls in the rejection region, or more specifically you can directly measure it as the case of rejection in the right tail. So therefore, since chi-square calculated falls in the right tail rejection zone or region, therefore it can be concluded that the standard deviation of wages is significantly greater than $10.